Okay, hello everybody. My name is Rick Moy. I'm the head of product at Accuknox. Tell you a little bit more about the company when we get started. But we're a zero trust runtime security company primarily with other offerings as well. But today I'm going to talk with you guys about zero trust runtime security for the edge in particular. Some of the myths involved with zero trust, some of the challenges as well as objectives and what makes it difficult, and some tools you can use to affect this positively. So first of all, about the myths. There's a couple. One of them is that zero trust is only about network, right? So that's because there's a lot of network vendors selling zero trust for networking. Some people think it's only for the cloud or primarily in the cloud. That's not true either. And there's also a myth that it's easy to implement, which it is not, regardless of your definition. So there's a lot of complexity in achieving zero trust. I like to say it's a journey. I know it's a cliche, it's a coffee mug slogan, but it's actually true. So we're going to get into this here in a little bit, and feel free if you have questions or want clarification, just raise your hand. So this is probably a little bit different security model than what you've seen. What I'm trying to show here is that if you back up and look at security, zero trust really it can start on the left side from the dev side and go all the way through to the production or runtime environment. And there's different stages in between, and there's different approaches to security that make sense at different levels. So at the beginning, obviously you can have source code helpers that try and reduce the attack surface, improve your coding. The static scanning, that's good, right? That's been around for decades. We know what that is. Scan your app, or in these days images or containers, find out what the vulnerabilities are, gather that information. Hopefully you can go and patch that. No, you can never patch it all, right? You're going to have thousands of vulnerabilities across your estate, and you're going to have to make some decisions on how to live with it. So when you get to the admission part, an admission is simply, it's a great tool to have, but it doesn't reduce your attack surface nearly enough. Some folks confuse admission with runtime because the admission controller process dictates what can get past that gate into the runtime, but it doesn't actually protect the applications at runtime when they're actually running. So they can be great for making sure that devs don't automatically push latest tags, right? That they should be specifying, for example, specific tag versions so that they know what's in it. Having a CVSS score of under 8.5, right? That's a good gate. But then after that, the code inevitably gets into runtime, and you have other considerations from an attack surface perspective that need to be addressed. And so what are those? You probably can't see the color very well, but on the left side is your typical runtime environment where it's all green. We start with an app, and the app generally, who knows what it does? The developer made it, shipped it to production, and it's there. You have known exploits or known vulnerabilities which can be exploited. You have some patches that are available for those. Whether or not those are applied or not is a different question. And then you have unknown vulnerabilities, so-called, which can become 0 days if an exploit's written against it, and then we all find out about it. Apache struts, log4j, a number of other things that we've seen in the news. And these don't only come in through the application. They can come in through the data vector, right? Through SQL injection. They can come in through code that's hidden and then later activated. They can be configuration oversights or misconfigurations due to drift, right? So that's the right? We have a fairly large attack surface that we then try and ratchet down with different controls, firewalls, access rules, things like that. On the right side is really more the desired state we want to get to, right? A smaller green field, a smaller attack surface of what's permitted, and a larger, area which is not permitted. And so zero trust really starts with a deny default. So don't allow anything, and then specifically enumerate the accesses and activities that you're going to permit in your application. So if your application doesn't need access to a database or another microservice, why enable it? Because if one of those other services are owned, that's a vector into your application, and vice versa. So that's the whole principle, right? So easy, right? No, it's there's a few challenges with that. So what are the challenges to getting to a zero trust runtime security posture? Well, for one, these apps are they're not standing still, right? There's continual updates that are happening, and oftentimes the developers don't know exactly the ramifications of all the changes, right? Because we're all using open source libraries to some level, right? Those aren't necessarily, controlled and scanned as well as they should be. People make mistakes, so there's a lot of ways that bad code can get injected into the process. So understanding what the app should be doing is non-trivial. You're going to have a range of different workloads in your environment, and they're going to be at different stages of maturity. Meaning some are going to be maybe very high visibility, critical, so you're going to want to err more on the side of caution versus the side of locking down. So you have to have those decisions be made. And by the way, I didn't mention it on here, but it goes to repeating. It's worth mentioning this is an organizational and a cultural issue as well. It's not just a technology issue, because you have the developers, the ops people. Sometimes we put them together. Or they have mixed titles, and then you have security. And are they looking at the same thing? Are they sharing information and collaborating? That's a common friction point in teams, especially larger teams. You needed to be able to apply a strategy for applying different policy levels at different stages for different applications. So not every application is going to have the same one-size-fits-all policy. And so you need tooling that enables you to have that fine-grained control. And that tooling has to encompass the application, the processes, which ones are called, which ones are, do you allow to fork, which ones have access to the network. Not every app needs to talk to the network. Not every process should talk to the network. And the data access. So there's a number of factors there. And if you take this and consider, okay, I was just talking about the data center, right, in the cloud native to start with. Now if you look at doing this on the edge, there's a whole other set of considerations, right? So you have maybe less bandwidth, so your latency is more of an issue. Maybe you're in running on a particular OS that needs to be locked down and in a closet and not touched for a long time. Maybe that's tied to other physical processes in a certain way. You've got latency issues. Maybe it's not always available to talk to the network. So you have to take those things into consideration. So quite a lot to think about. A little bit about, from our perspective, and where we're coming from. Accuknox is a venture-backed startup company, Silicon Valley, all that started life partnering with an organization called SRI. These are the guys that invented a lot of technologies we're using today. They were the first ones to assign domain names. And they had done some very cool research into the low-level processes within the Linux kernel, and had started to develop some technology that they wanted to take to market. And so they partnered with us to do that. We're also working in the 5G space. We're members of the, can't remember the acronym, the Open 5G Network organization. And so we set out to do this specifically from an application hardening perspective. We have two or three, I think three now, different open source projects one of which has been contributed to CNCF, and it's now a sandbox project, and I'm going to talk about that more. It's called kubearmor. We also have a discovery engine which does application behavior, and we've been contributors to Cilium for the SPIFFE workload identity projects that go into that CNI. So this is important in the context of what I want to talk to you about is what are some ways that you can use this open source technology to achieve zero trust at different levels. So this shows here two different, basically the flow. If you look at kubearmor, which is, I'll talk about Kubernetes first and then apply it to, how it might appear in the edge and in different formats. So think of us as a daemon set. We're a host-based application that does enforcement of policies, right? So let's assume you know what policies you want to apply. We enforce policies at the process, file, and network level using known Linux security modules. These primitives like AppArmor, SE Linux, and now BPF LSM. That's how we do our enforcement. So we basically generate those rules to be applied because they've been around for decades. They're proven. The DoD loves them and approves of them. They use them. The main challenge with those is that it's very hard to know, who wants to sit down and write those rules, right? And the likelihood of getting it wrong is fairly high. So that's where the discovery engine comes in over here on the right by looking at the telemetry that kubearmor can generate by looking at eBPF system calls down in the kernel. We generate this telemetry along with CNIs like Cilium and correlate that with Kubernetes metadata. What's the node this is running on, which pods are in there, namespaces, things like that. So we can take that information and link it to syscalls that are permitted or not permitted. So as you can imagine, there's a lot of data that gets generated, right? Maybe too much data for the human. And that's where the magic comes in of aggregating this and making sense of it so that it can be turned into policies. Over there on the right, it spits out YAML files, basically manifests that can then be applied through normal Kubernetes operations to be applied in cross clusters. So that's the basic process of how that works, and we thought it was very important to not introduce a lot of new things, but to leverage the tooling that was already there and tried and tested. So, like I said, we built this for Kubernetes, and then we started talking to the good folks at IBM, and they were working on OpenHorizon, and said, hey, what you've done is cool, but could you make it work at the edge? And long story short, yes, we could, and we did, with a few tweaks. So we're able to run, in an edge Kubernetes and edge, I don't know what you call it, bare metal or native, right? So we integrate with OH Management Hub and to work in that environment. And those use cases are probably common whether you're working with any other edge type system, right? So first of all, you want observability for the workloads. What are the workloads doing? Observability for the host. What's happening at the host level? And then within the workloads that are containerized, we want to isolate those, right? Because the pattern is generally there's a management component and then there's an edge piece that's running software apps from multiple vendors, right? Maybe one's for home security, one's for lighting, one's for other things, or in a factory there'll be different providers integrating technologies onto a platform. So you don't want those to be able to talk to each other unless you've decided they should, unless they have a real technical and business reason to do so. Because if one of those neighboring apps gets owned, maybe, I used to run a company that did pen testing on products. You'd be amazed. Some of the apps go out with very poor security. So you don't want a neighbor's bad hygiene to bring your app down, right? So beyond the containerization of that or isolation, you want to be able to deploy various or different policies, right? So app A is going to have a different behavior profile than app B. So you need to fine-grain tune those policies per app. And the host as well, right? The host is on the network. It's still vulnerable. It's got lots of software that for which CVEs are being issued, right? So we need to implement a least privilege set of policies and hardening for the host OS as well. So those are all the main use cases. So what does a deployment look like? So like I alluded to, there's a management hub that's running, its core processes, and a number of different Docker containers, each with, there's a couple databases in there. There's HashiCorp Vault. There's an Exchange API, and a number of other things that then connect via the Exchange API to the Edge worker, the Edge host, via an Annex agent, which you can attach to over the command line API. And you see this kubearmor, which is the open source telemetry agent, which is running in there. And what it's doing on the right side is it's generating telemetry data, which is then analyzed by the discovery engine to then create. It's watching as the app is being running. Now, in an ideal situation, you're doing this, in a test bed, right, with your golden image, and you've got unit tests running through. You're exercising the code. You're using the application as it would really be used, right? So you're exercising the code paths in order to generate an accurate image or an accurate set of what we call insights into the application behavior that then gets distilled into the set of policies which can be applied. So that means that those policies down here in the lower center, they're in 3 different categories, right? There's network policies, so we can say this home assistant, right, which someone's going to connect to it via a browser, and there's always vulnerabilities in those things, right? That browser is only accessible, the home assistant can only be connected to on a certain port, and it can the only processes that can respond are curl and Python over TCP and UDP and raw. That's all that we're going to allow there. Anything else will be rejected. So that's a pretty tight definition. And we came up with that by help of the discovery engine. And the process level, you see there's BusyBox and S6 stuff in there, right? So there's a long list of things, and we've whitelisted those processes to run. And the same with the file. Now, files can be very tricky because you can touch, hundreds or thousands of files on a system just in the normal course of operation. So what we've done is implemented some aggregation and roll-up capabilities, so we can, whitelist entire directories. So there's some secret sauce in how we do some of that in the IP. Let's see. So that's the basic setup. So another use case with respect to this home assistant is it's important to not just manage files in general, but there's certain certificate folders which should be off limits. So we can limit which processes and users can access, the root certificates, for example. We can also, because we have certain pattern detection in there, and we can link certain, process activity to MITRE tactics and procedures. So, for example, software discovery. There's about, if you were to go on the MITRE attack framework, you could look this up. T1518, there's about 40 different tools that they've identified that attackers typically use to enumerate the software packages and versions that are being run on a system. And they can then use that to say, okay, well, I've got 5 vulnerabilities here that I could use. Which one do I want to exploit? And for system information discovery, there's, I think, about 200 different apps there. Things like Cobalt Strike, Dridex, a number of different tools. Let's see. So auto discovery, I think I alluded to this as a little bit more in detail. This was also in the bigger document, but you know, we're looking at all of these 3 vectors here: file, network, and process forking, generating tons of data. All this happens, by the way, within the cluster. If it's a well, speaking of reliability, I find that the Apple HDMI things are always the first. The cable's the first to go, right? Okay. So let's see. Let me just wrap up in summary. You know, OpenHorizon, we found to be a great partner working with those folks. It's a scalable edge architecture. You know, and the edge is I think an underappreciated attack surface now. Right? There's been a lot of focus shifting to cloud native. As you look at the edge, I think that's going to be a new area for adversaries. And when you have this unique scenario of multiple vendors having to, you know, put their, you know, integrate their products at the edge, what could go wrong, right? You just have a lot of activity there, and that you want to, you know, from a business perspective, you want to get to market quickly, right? The business rarely waits for security. So this type of an approach with these tools allow organizations to very quickly profile the app and say, this is what it's doing. I don't want it to do anything more than that. Now it's good to ship. And if something does happen to it, I can contain the blast radius of that attack. And again, having fine-grained, least permissive policies and to be able to apply that on a per workload basis is very, very important. So no matter what tooling you use, keep that in mind. But I do hope you take a look at KubeArmor. We're getting a lot of traction with this. It's a fairly new product, but we've already got 250,000 downloads on GitHub for it. So again, CNCF sandbox project. We're pretty proud of it, and you know, it's one of the. I think it's the only one out there that's doing what it's doing from an open source perspective too, with the eBPF telemetry. So that's all I wanted to share with you guys today. I guess this is we have a few minutes for questions. No questions? Okay. All right. Well, I'll be around if anyone wants to talk to me one-on-one. But otherwise, thanks for your time, everybody. Hope you have a great rest of your conference.